Combinations are all over the SAT, and some of you have probably been taught to do combinations and permutations in your calculator. A lot of times it doesn't work. You're going to find it works on some, and on others it doesn't work. So what I'm going to do is I'm going to give you a combination flow chart, which is essentially a series of questions you need to ask yourself to figure out the correct way to go about doing the problem and to arrive at the correct answer. But I gotta say, on a lot of these combination problems, at least 60–70%, you'll want to actually just write out all the possible combinations. If you look at the answer choices and they have small numbers in the answer choices, 25 and below, that's a signal to, you know what, I'm just going to write out my combinations and be on the safe side. If, of course, you see numbers in the thousands or 75 and up, you're not going to want to write out all your possible combinations. At that point, you either need to walk away from the problem or understand this other way of doing combinations where you ask yourself the questions you need to arrive at the right answer. But we're just going to do a couple right now, which just works with writing out our possible combinations. So this number 15, the integer 5,421, consists of 4 different integers that decrease from left to right. How many integers between 6,000 and 7,000 have digits that are all different and decrease from left to right? So I see numbers in the answer choices 32, 20, 26, 16, 36. They're not that overwhelming, so I know, you know what, it might be safe enough for me to try to write out all my possibilities. So we have 6, 5, 4, 3. Now let's keep the 6 the same, and we can keep the 5 the same, and we can keep the 4 the same, and we can change the 2. And then we would have 6, 5, 4, 1, 6, 5, 4, 0. Now there's nothing else we can do keeping the 6 and the 5 and the 4, but we can still keep the 6 and the 5 and now move to 3 and 2. Then the next would be 6, 5, 3, 1, and then 6, 5, 3, 0. Now there's nowhere left for me to go with 6, 5, 3. But I can keep the 6 and the 5 and go to 2. So it would be 6, 5, 2, 1, 6, 5, 2, 0. Now I have to change the 2 to 1. I'd have 6, 5, 1, 0. Is there anything else I can do with the 6 and the 5? No, because then I would have 6, 5, 0, and I have nowhere to decrease down to. So that's all we can do with 6, 5. We can still keep the 6, but we can move the 5 to a 4. So we would have 6, 4, 3, 2, 6, 4, 3, 1, 6, 4, 3, 0. Keeping the 6 and the 4 the same, 6, 4, 2, 1, 6, 4, 2, 0. Keeping the 6, 4 the same, but changing the 2 to a 1, we would have 6, 4, 1, 0. There's nothing else we can do with the 6 and the 4, so we move to 6, 3. 6, 3, 2, 1, 6, 3, 2, 0. Change the 2 to 1, 6, 3, 1, 0. Nothing else we can do there, but then we have 6, 2, 1, 0. And are there any other possibilities? No, because you'd have 6, 1, 0, and we'd have nowhere to go. So how many possible values did we get? 20. So the answer is B.